Welcome back. We're going to move on to range and variability. So this is actually quite simple and a nice one to start back in the first day back. So just a reminder what we did before the midterm break. We did averages, finding the mode as a type of average, the mean as a type of average, and the median as a type of average, and then we got it from tables. So that's what we've been doing before midterm. The range and variability just says how spread out the data is. Okay, so the yellow box, the range is the largest value, is the difference between the largest value and the smallest value. So make sure you take down that. There's no actual examples in this, like official examples, because it's that easy. If you look at the range, it's the biggest number, 28 take away 3, the range is 25. And the range shows how spread out the data is. So if it's a large range, the data is very much spread out. If it's a small range, all the data is together. So for example, like I said, if I was to take the range of all your ages, it would be quite close together. It would be 1 or 2 years at the most. 1 year. Whereas if you were to put my age in there as well, the data would be more spread out now, so the range would be bigger. It's not an average, it's just saying how spread out it is. Okay, so no different. We've done the averages, this is the range. So what I want you to do is take down subheading range and what it means. And then if you're ever asked to compare data, to compare two sets of data, we use the range and either the mean, the mode. We generally use an average and the range to explain. So you might say, on average, someone scores more in a match, but the range is very spread out. Okay, their data is very spread out. So say for example you could have a player, let's go 5 matches. We're talking about basketball. Let's say basketball. A basketball player scores 30. So hold on 1 sec. Okay, sorry. We look at these 2 basketballers. Let's find the mean. Let's just go, for example, find the mean of these. Add them all up. 5, 35, 37, 37 and 35 is 72. 72 and 28. That's 100. Divided by 5 equals 20. This guy has a mean of 20. This guy, 20 and 18, 38, 55, 55, 79. This is a total of 100. So he has a mean of 20. They both have exactly the same average, exactly the same mean. However, if we look at the range of this guy is 35 minus 2 is equal to 33. The range of this guy is 24 minus 17 is 7. So you can see this guy's data is spread out, where this guy's data is more packed closely together. The range is small, the range is large. Now these 2 basketballers, they've got exactly the same average. But when you compare the averages, they're the same. But when you compare the ranges, this guy's range is much bigger, meaning his data is more spread out. Now look, he scores way higher in certain matches, but in certain matches he scores less. So the word that I'm looking for sometimes that can be involved with range is consistency. Okay, so again, it's up to you which one basketballer you choose. There's reasons for picking both of them. The reason for picking this guy, if you were to pick him, is consistency. This guy, he's likely, or there's a chance that he'll score you quite a big score, but there's also the chance that you go low. So when you're comparing 2 sets of data, don't always just look for the big numbers. Think that what's the average, what's the mean, or what's the median, depending on what they ask, and what's the range. Is the data spread out? Is there low values in there? Is there high values in there? Alright, so I don't need to take down any examples for range. I'll get you to try a few questions, and if you have any questions about it, please ask.